Okay, we have a lot of ground to cover in a very short period of time. But for those of you here, I'll tell you a secret real fast. If you get through this session with me and then the one with Edson right after this, we actually have something special for you. If you send out a tweet with a picture of myself or Edson, and of course, hashtag JavaDay 2016, we have some of these super cool Code is My Spirit Animal t-shirts. Not a lot of them, but we have maybe enough for those of you who are here. So send us a tweet, at Burr, Sutter, at Yanaga, hashtag JavaDay 2016, and of course, vote for us as good speakers too. We won't. But no, seriously, we have a lot of. I probably have about 60, 70 shirts or something like that, and we'd like for you guys to have them. It's similar in design. We do a lot of different designs of this particular one, and that's similar to this one. Okay. So that's my Twitter handle, at Burr Sutter. You can find me there. You can also just email me, Burr@redhat.com. And, of course, our website is developers.redhat.com. And we're part of the developer program for Red Hat. And we're specifically out there getting developers to engage with us from a community standpoint. You can also download all the various JBoss technologies, including Red Hat Enterprise Linux is available for download there now, too, free for developers, as an example. So this particular presentation is at bit.ly Reactive MSA. If you go to that URL right now, you'll be running the exact same slide deck that I am running right now. Okay? So let's get going. We're going to have to dive right in, and I keep a change history for the slide deck also. So if you go to developers.red.com, there's a number of things you can download from there, one of which is a microservices book. It is now, the homepage has changed, but you should still see a link on the page someplace for the microservices book. And that actually covers Spring Boot, Wildfly Swarm, and Drop Wizard, specifically around microservices. It does not cover Vert.x because Vert.x is very special, and you're going to hopefully hear about that in this session. Okay. There's a lot of different projects that Red Hat is involved with. It's not just JBoss specifically. And actually, let me do this real quick. If we have a few minutes, I want to tell you a story about JBoss, because this is one that particularly motivates me. I was planning on telling it during our opening keynote earlier, but we didn't get a chance to. And it's just a little story about how I got started with JBoss and how I got involved with open source. So back in January 2002, I know it's a long time ago. Some of you guys weren't born yet, right? I'm kidding. But January 2002, I don't know how it was here in the Ukraine or throughout Europe, but specifically, a lot of people in the US were unemployed and laid off. We had just finished up all the Y2K work, and we'd also just gone through the .com bomb. So, dogfood.com and all webvan.com, all the .coms had failed. And now you had a whole lot of people in the community that were unemployed. And we had a Java user group, and at the time, I had just become involved with the Java user group at that moment. And so we had a very small room. It only sat about 60 people, but we probably had about 120 people there. It was literally standing room only. People were sitting all over the carpet and everything else. And it was because at that time of year, at that time of life, we just had a lot of people looking for work. It was a very downtrodden kind of environment. There's a lot of people very concerned about the future of Java, the future of their career path as a software developer, and it was a very unusual time. And we actually had a very special event where we invited all the major application server vendors at the time to come in and speak to us. So IBM was there, BEA, when BEA was a company, was there. Sun was there with iPlanet. Borland was there with their app server, and Macromedia was there with JRun. And so we were going to basically have an app server shootout. All the app server vendors could present and tell us why their application server was so awesome. And there were numerous, again, there was about 60, 70 of us sitting down and about another 100, or a total of 100 people in the room. And so there was one fellow who walked in wearing a T-shirt, pair of jeans, pair of flip-flops, no computer, nothing else. And then the organizer said, oh, I recognize you. You get to be number 7 in the panel. And he just walks up beside all the other vendors in their nice suits and their ties. And then, so it just kind of goes on like that. So every vendor gets up there and says, oh, I want to tell you what's so awesome about my application server. It's got this feature, we got EJB this and servlet that, because this is back in the day of J2EE and EJB this and servlet that. And they all gave their different presentation. They talked about their technical advantages. Here's why ours is so awesome, why WebSphere is so awesome, why WebLogic is so awesome, why Borland was so awesome, iPlanet was so awesome. So many of these vendors are no longer with us. And they also had to say how much it cost for each developer. That was very critical. So they would say, okay, it's only $2,000 a developer. It's only $1,500 a developer. It's only $1,000 a developer for a developer seat to get access to these technologies. And so think about that for a second. A large portion of the people in the room are unemployed at this moment. And here we are hearing about $2,000 for this and $3,000 for that. A good example of that was object relational mapping software was $80,000 a server at that point. This is the world we lived in January 2002. And then at some point, I noticed the fellow who walked in his flip-flops waited for one of the other presenters to finish and whispered in his ear. And I watched the other presenter hand his laptop over to this fellow with flip-flops. And so it was Mr. Flip-Flop's turn to get up and speak. So he gets up, he plugs in the projector with his laptop, and he says, "My name is Mark Fleury, and I want to thank this gentleman here beside me who let me borrow his laptop in true open source fashion. He's contributing to my effort. I built my slides right there. I watched him do it because I was sitting in front of him." And he goes, "I want to tell you guys about JBoss." And it's specifically, you heard all these vendors talk about all their great features and all that. Let's first talk about our price point, all right? How much is, $2,000, $1,000? Here's our price. He hits the next slide, and it says, free. Now, this has everybody's attention at that moment. There are people giggling. It's a claustrophobic hot room, and everybody's like, "Oh, wow, that's interesting." And he goes, "But most important, let me tell you about our key technical competitive advantages." And he hits the next slide, and it says, "doesn't suck." And so this presentation went down in history as the free doesn't suck presentation. And from that one presentation alone, people chased Mark Fleury out of the room and said, "I work for you now," literally. I wasn't one of them, though I did end up at JBoss a couple years after that. But from that one night alone, 6 or 7 of us ended up working for JBoss. And I started with JBoss in 2006. I got acquired by Red Hat as part of that acquisition, and I've been with Red Hat ever since. But if you think about how the world has changed in the last 14 years, free doesn't suck has actually changed the world. And so I fundamentally love open source, and I love working with open source technologies because it fundamentally changed the world. We don't have to spend $80,000 on object relational mapping software anymore. We now get Hibernate for free, right? We don't have to spend thousands of dollars per developer seat for the Borland application server and Borland toolset because it was super cool back then. We get Eclipse, we get IntelliJ, we get NetBeans for free, and we get, of course, all the application servers for free. So in this world, Red Hat does a lot with open source. We open source everything, and so there's numerous projects that fit within this developer space. We're going to talk about Vert.x today. And is there anyone here who's already used Vert.x? Okay, only 2 of you, 3 of you. So there might not be a whole lot of net new in this. This is more of an introductory presentation, but hopefully it'll be fun for you, and we'll go ahead and get moving along. Okay, so let's get moving. Quickly, to give you another little history lesson, in the world of developers, we've had to learn a lot over time. So in the 70s, we might have had to do COBOL and JCL and Wiffle, right? I actually did Wiffle on a Unisys mainframe. I didn't do JCL. I wasn't one of the cool kids. But we had to do COBOL back then. But it was real simple. You might learn 2 technologies in the mainframe era: programming language and whatever JCL command language that you had. That was it. You learned 2 things. And then in the 80s, you might have learned C++, and I heard a lot of people earlier say they did C++, but you might have also experienced 4GLs, back when 4GLs were super popular, and CASE technology, computer-aided software engineering. That was what predated Rational Unified Process and all the UML stuff that would actually drag and drop and generate our applications. But we had to learn SQL, and we had to learn Unix, and then we had to learn things like HTTP, get, put, post, and delete in the 90s. We had to learn about cookies, and that cookies were not going to steal your credit card. You remember back when cookies were going to steal your credit card and basically steal your identity? And you might be thinking, no, they don't. Exactly. But we didn't know that in 1994. In 1995, we actually thought identity theft was going to happen due to HTTP cookies. And so a lot has changed over the last several years. As you can also see, we might have had to pick up servlets. We might have learned Java in the late 90s, EJBs, et cetera. And then, of course, in the OOs, as I like to think of them, we picked up model view controller from Struts. And that was another big thing that really got us going in the open source community within Java, was Apache Struts project and the Jakarta project at Apache, right? We learned dependency injection later on, a few years after that, through the Spring project. We learned object relational mapping through Hibernate. And these things were all open source and available to all the Java community. But you see, it just keeps going on and on and on. We then had to learn Ajax, Web 2.0, JavaScript in the browser that interacted in an asynchronous way with the server. We had to learn that as an example. We learned about automated testing, CI subversion. And then if we keep going, even now, right, in the new decade that we're in, where you do HTML5, we had to figure out mobile. We had all these smartphones. We might have learned Cordova or Apache Cordova or PhoneGap. We learned maybe Node.js. We had to figure out Git instead of subversion. But my point with this is it just keeps on coming. Right? We got to keep learning, got to keep learning, got to keep learning, and that is just the nature of the beast. And at some point, you will be the mythical beast. But this presentation is around Reactive Microservices with Vert.x, and there's yet one more thing to learn. And I want you guys to think about learning it, and I encourage you to learn it. That's why I'm here, because it's actually super fun to work with Vert.x. It's a very fun programming environment, and you'll do some very clever things with it. So hopefully that gives you some greater context about where we are in history. But let's go ahead and dive in. So in a normal Java E world, right, J2E world, Java E world, you used to have an operating system, a Java virtual machine, an application server. You might have had a big old EAR file. I've seen people with really, really large EAR files with multiple WAR files, many jar files. And the reason this really mattered is because all of this had to be bundled in a single monolithic deployment. And you would deploy that whole thing as a single unit. And here's the real challenge. Everyone had to agree on the version of the operating system, the version of the Java virtual machine, the patch level for each. We all had to agree to the same application server. We all had to agree to the same third-party dependencies, like we're all going to try to use this version of Spring or this version of Hibernate as an example. All those things were part of the equation. And and if you think about that, we actually had a large portion of people who had to agree to what that thing looked like. Large number of people, like maybe 30, 40, 50, 100 people. And that's why it moves so slow. Because think about it, getting 41 people to agree to anything, let alone the same version of the JVM, same version of the operating system. And this monolithic architecture is now what we're rebelling against and why microservices, the microservices architectural style, is so hot. It is so cool. And developers in particular, they want to break this paradigm and run away from this architecture. They're tired of ears, they're tired of monolithic wars, and they actually want to break it all up into little pieces, and then they can deploy it independently of each other. Okay? Go. Next slide. Okay? So the idea is you break it up. So that's kind of it from a microservices architecture standpoint. It doesn't have to be much harder than that. You break it up so that now every independent team can deploy their component as fast as they wish to based on their version of the operating system, their version of the JVM, their version of the app server, or forget about all that. I'm doing Node.js, or I'm doing Ruby on Rails, or I'm doing LAMP stack. You can pick and choose what you want. That's why developers are so excited about it. They think they can now get away with it and not have to listen to the enterprise architecture team or the operational team. But if that's what you want to do, I encourage you in one area to think about this one thing. If you're going to go down that path, you need to assume accountability for your application in production. No more frontline support and no more operators working all night or all weekend when you throw them a bunch of garbage. If you give them a bad WAR file that doesn't immediately deploy instantly and easily, that's on you. You're on the pager. You're the one who stays up all night when the app does not want to deploy. And if you take on that accountability and that responsibility, then perhaps you also get the freedom to choose what you want. So I know that sounds kind of odd, but I'm seeing that in a lot of places where people are like, no, I don't want accountability, I just want the freedom. You got to have both, okay? So at a high level, if you look at the key microservices principles and characteristics, deployment independence is by far and away number one. This is what gives you the agility that you want from a microservices architecture. I want to be able to deploy not this whole big ear with all the wars and all the jars, all with the same app server, same JVM, same operating system. I want to deploy this one small component, all wholly on its own, based on its specific needs, and more importantly, deploy it when my business needs me to deploy it. If that means once every week, or if that means 10 times a day, doesn't really matter. I can deploy that unit by itself. That's the most critical aspect of it. So the good news is about criteria number one. Notice it doesn't matter if it's Java or another programming language, or if it's .NET. I don't know if you guys have seen .NET on Linux. It's pretty interesting stuff. It might be Node.js. It might be Ruby on Rails. But deployment independence actually matters a lot. And specifically, what we've been doing, and you'll see in my next presentation, we do tomorrow, is we actually wrap that as a Docker image and deploy it through Kubernetes, as an example. And that gives us greater deployment independence. Then you can do blue-green deployments. Then you can do canary deployments. You can push it through a CI/CD pipeline. We're not going to focus on that too much in this session. Edson will talk more about that later today, and I'll visit that again tomorrow. But we're going to focus specifically on the Vert.x aspect of that. Okay? There's a number of other key properties here, like organized around business capabilities. You focus on products, not projects. Again, you take accountability for that application. It's a product in production. You own it. You own the API. You guarantee backward compatibility. You own it for all your customers, all the other people who invoke it. You own it as a product and as a product owner. And therefore, you ensure the stability, the scalability, backward compatibility, and security and reliability of that component. That's how you have to start thinking. It's not a project that ends and you walk away. It's a product you own forever. The team stays together forever, owning that product until eventually the product is retired. That's another example. Very API focused. You'll also hear things like smart endpoints and dumb pipes, and we'll kind of show you some of that in some of the demo applications. But this just keeps going on and on. I don't want to spend a lot of time here. We'll talk more about microservices in greater detail tomorrow, but just know that these are the key properties. Okay? There's next session with Edson specifically. That's him sitting in the Iron Throne. But he'll be talking about how to break up your monolithic database, which is a great session as an example. So we'll keep going here. All right, key microservices concerns. You'll see some of this in action today and tomorrow, but I'm going to focus primarily on basic discovery and resilience. But these are all the key properties you want to think about in microservices architecture. What do your APIs look like? What's your invocation model going to be? I'll show you an HTTP invocation model as well as an event bus invocation model. You got to think through your deployment pipelines. You got to think about your packaging of that. Is it going out as a Docker image? Are you running it in something like Kubernetes? Are you going to have specialized monitoring, specialized logging? All of these things you need to consider when you talk about rolling out a microservices architecture. Okay, but let's focus on Vert.x specifically. That's why we're here. I don't want to keep going here. And so Vert.x is specifically a toolkit for building reactive applications on the JVM. Toolkit here is a key word. It's basically something you throw in your POM XML that gets downloaded from Maven Central, and you're off and running. And that's it. It can be as lightweight as that. A single POM XML entry that goes in your Maven build, and you now have access to the Vert.x APIs. You are responsible for building your application around it, but this is embedded inside your application. And so that's why they refer to it as a toolkit. I will show you how to do web applications, microservice applications, things like that with it. But by default, you can do anything you want to with it. It's just an asynchronous programming API that you can take advantage of within your app. Okay? So it's unopinionated by default. That might be something that bothers you. It might be something you find to be great. In other words, unopinionated means we're not going to tell you how to architect specifically a web application around it, though we'll show you several examples. We're not going to tell you how to do a microservices-style deployment or a monolithic deployment, because you could do either one with this kind of architecture. It's unopinionated from that perspective because every end user of Vert.x will have their own way to take advantage of Vert.x. You might have your own specialized tooling you want to wrap around Vert.x as an example. I'll show you with Maven, but if you want to use Gradle or Ant or Make, you could, as an example. You want to use different IDEs? No problem. You want to use VI? In my case, I'm going to use Xcode, or sorry, not Xcode, Visual Studio Code, because it's the editor I like using right now as an example. So we'll keep diving into this. So let's talk quickly about Reactive. I thought we were supposed to be proactive. Do you guys read this book? Who knows what book I'm talking about? It was this book, 7 Habits of Highly Effective People. Number 1, be proactive, not reactive. And here we are talking about reactive programming and reactive systems. I just always thought that was funny how we used to beat people up. No, you want to be proactive, not reactive. This is just a joke, by the way. But Stephen Covey, and if you've not read the book, I highly encourage you to do so. Okay? So the Reactive Manifesto defined very specific attributes of what a reactive system looks like. And there is a distinction between reactive programming and reactive systems. The first of this is be responsive. That seems pretty trivial, right? You have to be responsive based on the needs of your users and the customers who are going to consume your resource, consume your service. You have to respond in the appropriate time that you're supposed to respond. In other words, you have an SLA, and you will respond, period. That's as simple as that. You've got a responsive system. It has to be elastic. It has to be able to scale up easily and scale down easily. If I have a bunch of load and I need to scale out, I need to be able to add additional resources, add additional JVMs, additional containers, additional CPU, additional memory, and scale it out. And when I'm done using those resources, scale it back. So responsive, elastic, go hand in hand pretty much. Resilient is pretty obvious also. The system needs to be responsive and resilient to failure. And in a microservices architectural style, you focus on failure a lot because things will fail. And I'll show you an example of that in the demonstration. So if things break, because they will, your system doesn't fall over and die. It keeps working in a, let's say, a lesser state. It's not going to be working in a perfect state because things have failed, but you need to be able to respond to your users based on your SLA, regardless of what other downstream things and other dependencies might have failed underneath you. And of course, message-driven, asynchronous message-driven. And everything in a Vert.x architecture is based on asynchronous message passing. Everything's done with a non-blocking event loop, which we'll see in a second. Okay? So there's two major distinctions in the reactive world. There's reactive programming, and you'll see people talk about RxJava as an example, and RxJava can be integrated with Vert.x. But also there's a concept of reactive systems, and that are the whole systems adhering to those four key attributes of resiliency, responsiveness, elasticity, and message-driven. So we focus more on the reactive system side of it. We want to make sure that you can build such a system with Vert.x in particular. And so you'll see, in the case of Vert.x, this concept of the event loop. So this comes from Node.js land. So typically, if you think of a typical servlet architecture, a request comes from the browser in HTTP GET and HTTP POST. It invokes a thread from your thread pool, the user thread, if you will, which means you can do things like user local variables or thread local variables. And then you would invoke, let's say, the JDBC driver, and you would wait for a response from JDBC driver, and you would get that SQL response back. You'd formulate it into a page and send it back to your user. But the whole time, right, you're blocking and you're waiting. It doesn't work that way in Vert.x, and this is where it gets a little bit weird. You basically have this concept of the event loop. The event loop is responsible for basically taking the request from the user and immediately finding the handler that needs to be invoked, invoking it asynchronously, and it goes back into its looping structure. So you'll see that here, right? So this is just pseudocode, but while true, get the next event, find the handlers who've registered for that event, invoke them, hand off the request to them, and then go back and process more requests. It's never blocking, and you never block the event loop. And that's an important part of it. So that concept is the core fundamental of what you see in Vert.x. Therefore, everything is programmed through this concept of request and handler, right? What is the event? Here's my handler. That's how you program it. And in the case of RxJava, you can use observables also. So we'll keep going here. Whoop. The one thing that you keep in mind about the event loop, it's a single thread, okay? That's one way to think of it from a Java threading standpoint. But you do get one per core. You don't need to worry about that. But just so you know that if you have a 4-core machine or an 8-core machine, there will be 4 of those running, 8 of those running simultaneously. So that is one way to kind of scale out a little bit further. Of course, you can add whole other machines into the architecture also. Okay? Here's an example of a specific vertical. We call these verticals in Java land, or Vert.x land, sorry. And you can see right here, it's pretty straightforward. There's a start method. There's a create HTTP server, request handler. There's the request, the lambda, and here's my response. In this case, it's hard coding. Every request that comes in on port 8080 gets this one response back. So the programming model can be very, very simple. And this is often how it looks, right? You just simply say, what is the inbound thing that I want to react to? And then what is the handler that gets invoked? And so we'll keep going here. Here's another example where you actually can get started super simple. You can just do a git clone. You can cd into that directory. You can do a Maven package, which produces a fat jar. You can see it right here. And then you do a java-jar. All right, so let's kind of show you those. Let's kind of walk you through those examples. I think it's much more interesting to see actual examples. Let's see here. And we'll go over here to, let's just go look at Hello World. That's the Hello World we saw earlier. And you can see Hello World. We'll do JavaDay. There we go. Come back to my command line. And one way, I'm going to actually do this 2 different ways. And Vert.x run. I'm going to use Vert.x run, which is a command line tool, which is actually pretty nice. So basically, you can treat Java as a dynamic language. You notice I didn't compile the Java code. I just said Vert.x run. It dynamically compiles it on the fly. And that's actually super nice. And the reason that's super nice, there's my JavaDay, is because it works kind of like Node.js or PHP or Ruby. So that was kind of the idea. Vert.x by default is polyglot. If you want to run it with Ruby or JavaScript or Groovy, you can. I use it all with Java, and every now and then I'll throw in some JavaScript. But you can do that through as a polyglot architecture. But in this case, the fact that you can just run it as a simple Java file, I think is super awesome. So if I want to come here and play with it some more, let's look at some other examples. Okay, so that's Hello World. Here's the Hello World JavaScript version of it. So the exact same thing you saw earlier, but with Java, JavaScript, and JavaDay. Let's do that. And Vert.x run. Hello World JavaScript. And there it's deployed. And there's Hello World JavaScript JavaDay as an example. So you can see that you can just build up your programming environment pretty easily by using these simple commands. And let's kind of show you a couple more things here, because I think there's some good stuff in here. All right. And all these examples, by the way, are on GitHub if you want them. Here's another one you'll see often in a programming model. You'll see this concept of a set periodic. So this is an asynchronous timer. So basically, every 1 second, it'll produce a message, which is kind of interesting. So Vert.x run, say it again. Let's see. So it's got to go through the compile phase and deploy it. And you can see it's just iterating, displaying those messages. And then if I look here at the route, this is where we start getting to the web world. You have the concept of the web router right there. And then you basically set up your router this way, and you basically say what you want your routes to be. I want to route all things like get, put, post, or delete to the root here, and it's going to respond with hello. Arrow get, put, post, and delete to goodbye responds with goodbye. And then we do our request handler, and then we do our create HTTP server there. So let's run this real quick. Hello world Vert.x run. Hello route. Let that run. And we'll go back here. Localhost 80, there's the hello, and then there's the goodbye. Okay? Well, did I not do that right? It would help if you get the right thing in place. How about that? Boom. There we go. Okay? So again, the programming model is super easy, and you can see that iterative programming model is super fun. There's actually a way to do dynamic reloads. I don't have that set up right now, but that's easy to do. If you want to compile it as a Maven project, we have that example here too. You can see here's the Maven project. If you look here, we'll actually show it in the editor. The Maven project, standard Maven project, source main Java, and there's the vertical, right? Same one you saw earlier. And then there can be tests associated with it. It does interactive or unit testing. And then you can see there is a target directory. So there's target directory. So if I do a Maven clean, target directory goes away. All right, target directory goes away. If I do a Maven package, target directory comes back. And we'll see. There it is, and you'll see a fat jar in there. All right, there's the fat jar right there. And then you just do a java-jar target, and then Vert.x start-fat, and then you run it that way. And so same thing you saw earlier, but now we're doing it with a Maven compiled application. Okay, let's look at that. There we go, and you can see that's from Maven. That's specifically the message I used there. Okay, but so hopefully that kind of gets you through the getting started aspect. Things are pretty straightforward, but if you get into the web world, and again, if you're thinking of microservices, typically you're going to worry about REST and JSON, but the idea is that you have a web browser make a request through the HTTP server, which is built right into Vert.x in this case, and Vert.x can listen to multiple protocols, not just HTTP. It's pretty much any TCP type protocol it can listen to. So if you want to make an FTP server or telnet server, you could with Vert.x pretty easily. It's just a toolkit for listening on whatever port you want, and then you decide what the protocol is going to be and react to it accordingly. In this case, it has some nice features for HTTP. You have your router, and that sets up, and the router is nice because you can actually say for gets on this URL, or post on this URL, or deletes on that URL, call this handler, and then, of course, it asynchronously responds back. And so if I look back over here, let's look at a little bit more complicated one, my web server. Okay, you can see there's my router again. There's the root. Here's goodbye. There's also a get on the endpoint, a put on the endpoint, a delete on the endpoint. In this case, we're using a method reference. You can see that it's this get goodbye, this get endpoint, and if I look down here, there's the get goodbye as an example. And it's just a very straightforward programming model for setting these things up. So if I want to come over here and run this real quick, 3. And so Vert.x run, I think it was server. Well, now I don't remember. My server, Vert.x run, my web server. I hit run there. It gets loaded. I use an incognito window so things don't get cached. All right, so let's go to endpoint, and there's the endpoint there. So setting up a REST-like endpoint, super straightforward. You can go kind of crazy with it. And it's about like that. So we'll keep marching along here. We got a lot more to show, and not a lot of time to show it. Okay, so here's an example of a more complicated one. This is from one of the example applications you can find out there, and you can read the blog on it specifically. But again, get, put, post, delete. That's how you set up your router against the URLs that you want. You can see an example of a parameter right there, the ID, and then of course the method reference to basically say, I'm going to run the delete code, the update code, or the get code, etc. There's also the concept of a static handler for just static assets, HTML files, JavaScript, PNGs, etc. We'll see that a little bit later. Okay. So a couple more things that are interesting about Vert.x. It has this concept of the event bus. So far we just showed you basic HTTP. HTTP should be pretty easy. You can do that with servlets. You can do that with any kind of programming language at this point in time. But one concept behind Vert.x is specifically this concept of the event bus. The event bus is an in-memory bus that all verticals, all programs running in the same JVM can speak to, and you can also speak across JVMs. So if you have 10 different JVMs running, you can also have the event bus shared across all of them. It's like a shared piece of memory, if you will, and then you write your code so that you can interact with it and send messages back and forth. It's also extended into a pure Node.js NPM, and it's also being extended into other programming languages. Someone's working on a Go client. There's also a Python client. So it's not just Java clients, right, within the JVM. It can be extended throughout, beyond the JVM to like pure Node.js V8 runtime. Or, when you'll see in a second, you can extend it right into the browser itself. And that's where it gets really interesting. Okay? So in the case of the Vert.x event bus, this is kind of what the basic syntax looks like. Here's what the publisher looks like. Right here, Vert.x event bus publish, and the name of the feed, well, it's the name of this channel, if you will, right? It's nothing more than a string, and you can define what that means, and that is basically how you would publish something out. So in this case, my feed and the message, and if you look at the, I have the publisher in here twice. I was trying to put the consumer code in there, and I did not. Let's actually go look at it, though. Let's go check this one out, because this is where it finally gets a little bit more interesting. So let's say here's my publisher. Here's the Java version of that. Okay, and so let's go and run that. Vert.x run my publisher, and I'm going to put a -HA here, and that the HA invokes the clustering. And in this case, it uses various clustering managers to do discovery, and then it basically sets up direct TCP connections between all the different JVMs. So there's my publisher. Okay, and I can also run my consumer. Let's look at the consumer code real quickly. And actually, this is a super simple one. You can see right here. I want to register on the event bus, consumer for my feed, and it's going to run this handler, see, my handler, and there's the body for that handler. So you can see right now, this guy's publishing, this guy's consuming, and that's what's happening. If I want to get crazier with it, let's see what else do we have. Vert.x run, my publisher RB, -HA. And so right now, we're going to actually add 2 publishers to the network. So we're going to have a Ruby publisher and a Java publisher. And then we have, of course, the Java consumer. So there we go. So there's Ruby messages coming in and Java messages coming in. If you look at the Ruby code, as I mentioned earlier, it is polyglot. So if you want to write your code in Ruby, this is specifically JRuby, you can. Or Groovy, or JavaScript, you can. So here's a consumer in JavaScript. And if you notice, all the APIs look virtually the same. And that's because they are. They wanted to keep the programming model the same as much as possible. But you can see here now my JavaScript is going to connect. All right, so the JavaScript is a consumer. So there's a Java and Ruby publisher and a Java and JavaScript consumer. And what else do I have here? I have a Groovy consumer, Groovy. So Vert.x run my Groovy. Is that what I called it? My consumer. .groovy -HA. And so now we have 3 different consumers, 2 different publishers, all just cranking away on this event bus. These are all different JVMs that we've set up here. Like if I go here, you can see there's all these different JVMs. There's where they are. And if we want to get a little bit crazy here, I might just kill -9 one of these guys. Let's see which one I've killed. I just picked one at random, so I don't know which one I killed. So I killed, this one was, the JavaScript one is one I killed just now. And because I didn't shut it down cleanly, let's see if we can see it happening here. Oh, there it is. So what happens is when you do a -HA right out of the box, it basically says if that vertical is running anywhere and it gets artificially killed anywhere, let's say it runs out of memory and the JVM falls over, then it automatically restarts that same process in another one of the JVMs. And so in this case, my publisher is also now a consumer. But it works because it's all based on that asynchronous programming model you see in Vert.x. So this is kind of a fun thing to kind of test out and try those different operations out. But let's kind of keep moving along here. I got more things to show you. It gets crazier than this. Okay? So let's jump back over here to slide land, make sure we keep up with that. So that's the event bus, the basics of it at least. And actually, let me show you one more thing now I think about it. Let's show you I call it the browser bus. So you can actually extend the server, the event bus right here in this case, right, all the way out through sock.js into the browser itself. So if I come over here and run this, let's go down here. Let's go to the event bus one. Okay, Vert.x run, server. Well, what is it called? Oh, I'm in the wrong one. Browser. There we go. Vert.x run, server, SHA. And if I come over here to my browser, okay, there's a messages coming in now from the server side. And if I go back over here and actually run this other one, or even over here, yep. Okay. So in this case, I'm actually just publishing messages from different places within the bus, and then it's basically just pushing those out to the browser itself. Okay, so the idea is that the browser can actually be an extension of the Vert.x event bus. I won't leave all that running because there's just too much stuff running here. But the idea is you can basically push things directly out to the browser. Now this is where it gets interesting. I want to show you another example. This is one I built, and unfortunately I didn't get it ready I was going to deploy it for you guys so you guys could actually run it yourself, but I didn't get a chance to do that. But let me show you this. So the server-side piece of this code is super simple. It basically sets up a route for painting. You'll see what I mean in a second. It does the bridge, which basically says bridge to the sock.js across the event bus. This means the client is now a first-class citizen on the event bus, and that's it. There's almost no code in this server-side code. The interesting code is in the client side. On the client side, what this guy does right here is allow you to draw on a canvas images, and it sends every stroke you draw on the canvas through the event bus on the server side to all other listeners on the server side, which is also another browser. And if I had this set up for you, you could all be drawing, and we'd all be seeing each other's drawings. So the reason that's important is if you guys have used Google Docs before, or Etherpad, and you've seen the concept where multiple users are all editing the same document simultaneously, this is the same kind of idea. And if you've always wondered how you would program that, here's the way to program that. Okay, so let's see if we can show you that real quick. It's a different directory. I've got so many things here open. I probably have a different one open for that one. Yeah, there we go. So let's do this. Let's run that one. Come on, not you. Did I leave one of these guys up? That's the downside. We're running too many different JVMs. Oh. Here's the easiest way to deal with that. Okay? Maybe it's that one. Let's just get rid of some of these things. Okay? When you have too many different JVMs, let's see, did I get the right one? Yeah. All right, good. All right, let me double check that I did everything correctly. Let's see if I have any errors. No, good. All right, so basically this client is just a little canvas with these little color changes on it. Let me also bring up the dashboard. I'll just bring that up over here in Safari just so you can see that it's different. And let's see if that guy will connect for me. There, okay. All right, so let's do this way so you can see. So this is, I'd normally, like I said, I would deploy this like to the entire audience, and you guys could be in here drawing, so you could put in, you know, a nice little smiley face kind of thing. And if you notice what happens there, each stroke is showing up in this thumbnail, and actually it works across multiple users. So if I come in here and say I want this, each stroke, right, shows up. If you notice, it's in real time too. So as soon as I take the finger off the screen, the stroke goes through the entire system and reflects out to everyone else who's looking at the system. There's almost no server-side logic in this. It's all client-side logic. The event bus is set up to basically reflect all the way through. So I don't know, it's much more interesting if I let you guys play with it, but you can kind of see that if you think about it from a Google Docs standpoint, you've always wondered, how would I build something like that? This is how you might do it, as an example. So it's a very fun little application. I got to get running at some point, but we'll kill that one for now. All right, we'll keep marching along here because there's a little bit more we want to cover, a couple more examples I want to show you. Hopefully you guys are okay with this kind of example-driven way of doing it. This is kind of how I like doing presentations, is kind of showing people a bunch of stuff. So let's talk quickly about some specific microservice patterns. So this is in the world of retail. You might actually have the client, let's say the mobile browser, interact with several server-side components. You got to deal with cores, cross-origin resource, you know, but other than that, you can say from the browser, call A, call B, call C, call D at different URLs. And that's a very common paradigm. So you see it a lot in the retail space. There's numerous retailers. This is exactly how they architect from a microservices standpoint. They make those invocations. So in this case, the star rating, the price, the description, the thumbnails, and more importantly, the 15 available in a store near you is exactly how they would handle that, okay? Now, in a microservices world, you got to think through what happens when things fail. So let's say the location-based inventory is not available. In the case of like a Walmart as an example, it's back on a mainframe. So sometimes it doesn't execute, and they need to come back with a default answer. And so if the default answer is, we can tell you what your closest store is, but we can't tell you that you have 15 available in that store. So this concept of fallback or failure mode is super critical in a microservices architecture. And this is one of the primary things you have to kind of get your head around when you deal with the distributed systems and where service A calls service B calls service C. The specific thing you'll use in this case is called a circuit breaker. Circuit breakers and bulkheads were first defined in the book called Release It from many years ago. And I highly encourage you to read the book called Release It. That's the title. Because it walks you through these patterns and paradigms, and it gives you lots of great war stories about where systems have failed and caused cascading failures, because that's what you want to avoid. But let's do this. And you can also set things up where you take all that client-side logic, put it on the server side as the API gateway. And again, if something fails, you have to capture that failure here. You might also chain things together, and I can show you an example of that, where literally A calls B, calls C, calls D. And for some of you, you're thinking, well, what happens if something fails here in the middle? And again, you use a circuit breaker for that. So let's show you a very specific example of that that I have running here. Let's see how quickly I can get it up. This is what happens when you have too many things running simultaneously. All right, so this is where we'll run A, we'll run B, we'll run C, and we'll run D. I think I did that correctly. And let's go over here and see what we have. Localhost. Come on. Oh, it's called webroot index.html. Is that it? Oh, great. Now I've forgotten what is the URL to run this thing. Okay, it's in the README file. Oh, assets and assets. That's what it was. So over here, not webroot, assets. So this is exactly that you saw on the slide. Nope, if you got to spell assets correctly. This is bad, isn't it? There we go. So I put in Burr. I can't even spell my own name today. There we go. All right, so let's scroll this up so you can see it a little bit better. There we go. Okay. So basically, I'm making an invocation. Oh, why did it fail? My B failed, but this is actually a good example. So first time I went through A, B, C, D, and the next time this B failed. For some reason, B died on me. I don't know why. Let's see. Illegal argument exception. It doesn't like the word Sutter. Interesting. It doesn't like the space. That's what it is. There we go. So like in this case, you can see it's A, B, C, all invoked in that order. If I actually come over here now and kill, let's say, C, take it out of the mix, and I come over here and invoke, then we see A, B, and then C, and the fallback. So this concept of the circuit breaker is super critical in this space. So if I go over here and look at the B code, you can see where it does the get client, new JSON object, okay, asynchronous request, that's what the AR means there. And then if it fails, service lookup failure. Okay? Otherwise, handle the request. So this concept using the circuit breaker, you can see right here, build response, where is it at? Here we go. Circuit, execute with fallback. So the concept of the circuit breaker is critical. It's built right into Vert.x. When you see my presentation tomorrow, I'll show you specifically the same idea, but with Hystrix. Hystrix is better for traditional HTTP invocations and request response invocations, but they built one specifically in Vert.x to handle this specific use case. But this is the scenario where literally if I call out to another thing on another JVM, I'm not building a monolithic app anymore, I'm building a microservices app, I have to deal with that potential failure in the network, or if the thing is just not there, or more importantly, if it takes too long to respond. And that's the most insidious aspect of microservices, is if I call you and you're too slow, that makes me not meet my SLAs. My user's waiting. So at some point, I have to give up on you and respond with a default response. And that's specifically what we show here in the circuit breaker example. Okay, we're almost out of time. But let's see here. I might have a couple more things to show. So here's, example of the circuit breaker. Just going to bring that slide up. But this is, kind of how you would see it. So there's a concept of it being closed. It's just like the circuit breaker in your house, right? If you go to your wall panel, it ensures that you don't overdraw the circuit with, let's say, running a heater, running a curling iron, running a TV, and then if they overdraws the circuit opens so it doesn't heat up and burn your house down. I don't know if you guys have ever had that happen. If you actually go put your hand on the circuit in the wall in your house, after it's opened, you'll find that it's hot because it was getting too hot and the circuit opens. Same kind of concept here within the circuit breaker within software. So that was a super quick introduction to what you see going on in the Vert.x land, specifically for microservices architecture. I want to encourage you to go try Vert.x, try these things out. Again, all the slides are available. All these demos are available here, and you can see the slides again are at this Reactive MSA. And if you have any specific questions, we have about 1 or 2 minutes for a question. Is there a question that you might have? All right, one over here at the front. We have a man with a microphone. Yes, sir.
Thanks. Great presentation. Thanks a lot. So a question is, how do you integrate with Spring framework?
Spring framework? That's a very good question. So there are examples specifically with Spring specifically. So there's a whole example system out there, our example GitHub repo. So let's do that. And I've got so many of these things. Let's just do this. Vert.x, GitHub examples. You can see I've been to it before. And well, actually, there's a Spring example right there. So there is specifically a Spring API if you want to integrate. Boom, boom. And let's see if the repository has a good example of that. Whoop, click the wrong way. And, well, Spring did just a standard Spring repository in that case. Yep, so you have the full Spring environment if you wish to use it. Right. Spring Boot integration? Not specifically, because Spring Boot is not necessary here. You can integrate Vert.x as a toolkit into anything. So if you just want to use the Vert.x event bus, let's say, and embed that in a Spring Boot application, that should be fine. But Spring Boot basically will bootstrap a Tomcat or a Jetty or Undertow. Undertow is like the Wildfly web server. And that gives you the web server that you need. Vert.x has a web server built in, or it has any kind of socket listener built in. So you don't necessarily have to do both if you don't want to. Mm-hmm.
And another question, how do you test?
How do you test?
How would I test the Vert.x application?
Yes. So you would test it in the standard way that you would test any kind of application, if you will. But let me see here. There should be one of the examples. Specifically, let's look at the groovy one. Core, HA, event bus, and point-to-point. OK. Oh, man, this doesn't have it in there. But there's actually a test directory. There's a whole test framework built right into Vert.x specifically, just like you would run a JUnit test, same exact way. Right? So there's a whole test library for that. This example I was randomly picking didn't have the test directory. OK, other questions? Yes, sir? We've got a man with a mic running around here.
Hey, what kind of server inside Vert.x?
What kind of server?
Yeah.
Well, it just listens on anything port you might like. OK, so there is no server per se. Right? There's no Tomcat here.
I see. OK.
Yeah.
Okay. How I can monitor system, my application? So like in previous presentation, we see that Spring Boot have something like actuator and so on, so on. So Vert.x can provide such information about load, about memory, and something like that.
I mean, it runs within the JVM. It exposes attributes through JMX. You can run JConsole and JMX and see what you normally would see in that world. You can also instrument the event bus specifically to watch traffic flowing over there, since everybody who taps into that event bus can wiretap in, and you can watch the messages if you choose to. So there's lots of different ways to hook in monitors, and the default is just using the JVM's basic capabilities using JMX is what most people seem to like doing. I use JMX a lot as an example, just to kind of look at the attributes of what's happening in the JVM. What was that again? No container? Right, it's the JVM is the container. Okay, and we're out of time. Okay, if you have other questions, feel free to come see me afterwards. Yeah, get through Edson's session, which comes up later, and then send out those tweets, and we'll be queuing you guys up for one of these cool T-shirts that we have. All right, thank you guys very much. Did you get one?